I'll put this available. I'll put a link on my website. It'll be right there on the front page where you'll be able to get to this. You have 4 systems here. This is off of that page right there. This is what you want to be able to do tonight on your homework. You ought to. I would work best if by tomorrow you're finished with that section, page 8, and page 14, 4 through 7. If you went page 8, all of that page 8, 21 through 27, just the odd ones, and then page 14, 4 through 7. If you got that far tonight, that would be enough. That's going to carry you all through Wednesday, and depending on when we go over tomorrow, yes, our quiz would be Wednesday. But if we had run into any trouble, we can just kick it back a day. That sheet that you got right there, these answers that I'm going over, I'm going to take that up as you got it worked out. I'm going to work through it. That'll be like a little extra credit on that first quiz or whatever. Yeah. Okay, what it is that makes a system is 2 equations. Okay, that's if you've just got one equation, it's a linear equation, and you're graphing a linear equation. When you graph 2 linear equations on the same grid, that's when it's called a system. So a system is the idea that you have 2 lines or more on the same graph. Did that answer it? Okay. All right, so if I'm going to solve these for y, so 3x minus y equals 4, negative y equals negative 3x plus 4. Next step, divide by negative, so y equals positive 3x minus 4. So that's how that line, we're going to graph that line. So now I'm going to solve this one for y. 4x plus y equals 3. Just looking at it, we've talked about this. Here's an equation in standard form. When I work this out, if I have an equation that's in standard form, if it's positive, I should end up with a negative slope. And indeed I do. And so now what I want to do is, if I were asked at this point, was this what type of system this was, I could be able to tell you now that this is the independent system. That it has how many solutions? 1. Guys, that bothers some people that's one solution that has 2 parts to it. It has an x part and a y part. The x and y together represents the one solution to this system. It's the one equation where it solves them both. So if I graph y equals 3x minus 4, up 3 over 1, up 3 over 1, and it looks like this. So there's y equals 3x minus 4. If I wanted to graph y equals 4x plus 3, so I'd go to 3, go up 4 over 1, I run out of room. Up 4, left, so I'm going to go down 4 and right 1. Looks like I end up there on my solution. So the coordinates of that point are 1, negative 1, over 1, down 1. This is what I was alluding to earlier. Take the second, 3 times 1 is 3, minus a negative y, that gives me 4. 4 times 1 is 4, minus 1 gives me 3. This point solves both equations. This system has one solution, so we say it's independent. Anybody? All right. Again, just looking at number 2 there, I can tell that system, again, is an independent system. That system has one solution. Sometimes the questions are going to stop right there. They're going to give you a system, 2 linear equations, and they're going to say, describe the type, or how many solutions does it have? And the way you do that is you compare the slope and the y-intercept. Slope of this line, just looking at it, x plus 4y equals 12. The equation is positive. The slope is negative 1/4. Let's just take A over B. If you have an equation that's in standard form, the slope is always the opposite of its coefficients. And so when I have an equation here in standard form, the equation is 5x minus 4y. That's standard form. So the slope is going to be the opposite of that. So just looking at it, I can see the slope of the first line is negative 1/4. The slope of the second line is positive 5/4. They have different slopes. Everybody good? Different slopes means the lines intersect. Since they intersect, they're going to intersect in one place, so we know this is an independent system, and it would be over. Now, it's not over in this problem because what does it ask you to do? It asks you to take the equations, solve them for y, and graph them. So 4y equals negative x plus 12. Divide by 4, and I get y equals negative 1/4 x plus 3. Four. Down 1, 1, 2, 3, 4. What a terrible picture, but anyway, you get the idea. There's a line with what kind of slope? It's going downhill, so it has negative slope. And then I want to graph the other line. So if I graph the other line, 5x minus 4y, before I ever start this problem, I know what the answer is going to look like. I know the answer is going to have a positive slope. Let's see why. So negative 4y equals negative 5x plus 12. Divide by negative 4. What did two negatives make? So y equals 5/4 x minus 3. Up 5, 1, 2, 3, 4, 5, over 1, 2, 3, 4. Looks like that's where it should have. If I had drawn my line here a little bit better, they would have intersected there at 4, 2. So 4, 2 should be my solution. Come back up here. 4 plus 8. 4 plus 8 is 12. 20 minus 8 is also 12. So the 0.54 is the solution to this. I was looking around at some of you guys' work from earlier, and I noticed somebody, I can't remember who it was, they had these graphed and they did two straight lines right here and they graphed way out there and they didn't intersect. Okay? Because it was, they did positive 1/4 by accident right there, and so you couldn't tell over here where that's what this is for. That's what substitution is for. Sometimes it makes sense to graph a problem because it's not nice, neat, and perfect on one of the, anybody know what those are called? The point where it's like right on the cross of the intersection of two things. That's a tough word. You'd have to remember some really weird stuff. But anyway, it's a lattice point. When I refer to a lattice point, that's what I mean. A point that's right on the intersection of two axes, I'll call that a lattice point. Okay. So sometimes they don't have lattice points, and so we need another way to solve them. These do down here, but I'm going to go ahead and show you substitution. And the way substitution works is like this. You have to solve one of the equations for one of its variables. Which equation? Which equation do you solve? You said the first. Malik says the second. Which one's right? Both of them. Solve either equation. Guys, it just says solve one of the equations for one of the variables. So either I take this first equation or I take this second equation and I solve it for the variable that presents the least amount of work for me. Guys, there's nothing wrong with that. There's nothing wrong with taking this problem right here and just moving the 3x to the other side and being done with solving one of the equations for one of its variables. But Coach Hill, I didn't solve for y. I solved for x. I moved this x to the other side of the x. Yes, that's okay too. Now, if you wanted to, you could even solve it for y. You would just end up with some fractions. And like I said earlier today, that's what I'm going to warm up with class tomorrow. Is we're going to solve some linear equations that have fractions in it. And what we'll do is we'll take and we'll distribute and do all that stuff and then get rid of our fraction by multiplying by the common denominator of all the denominators. And it won't present that much of a problem for us. So now, what I've got here is y equals negative 3x plus 6. That's, I'm sorry. Let me see. Sorry. Minus 6. Thank you. Y equals 3x minus 6, negative 3x minus 6, and negative x minus 3y equals 18. Negative x minus 3y equals 18. So now, because this is the substitution method, what does the idea of substitution tell you you're going to do with that first equation? That's right. Plug it into the other equation. Have you done that yet? When you plug it into the other equation, I end up with negative x minus 3. I'm supposed to write a y right there. Right there, I'm supposed to write the letter y equals 18. But instead of writing the letter y, I'm going to go to the other equation and get what I solved it for to plug in. So instead of plugging in y, I plug, golly, I keep saying plus 6. Isn't it supposed to be minus 6? Yeah. I plug in that negative 3x, 3x minus 6. Now what? Now what am I going to do next? Solve it. Now, guys, the reason we did substitution, the reason earlier in the problem we did elimination, is so that you could go from 2 equations and 2 unknowns to 1 equation and 1 unknown. Because with 1 equation and 1 unknown, I can solve for that variable. But with 2 equations and 2 unknowns, I have too many things to solve for. Guys, we will eventually, in chapter 4, I believe it is, we'll get to 3 equations and 3 unknowns. With 3 equations and 3 unknowns, guess what the first thing you got to get it to is? 2 equations and 2 unknowns. Then what do? Get it to 1 equation and 1 unknown. Then you plug that 1 equation back into the 2 equations, get your second answer. Plug all that stuff back into the 3rd equation, and get the next answer. The same thing will happen with 4 equations and 4 unknown. 5 equations. We can work as many equations and as many variables as we, but what we eventually got to get it down to is this right here. 1 equation, that's 1 equation instead of 2, and 1 unknown variable. So negative x, negative times negative is a positive 9x plus 18 equals 18. So 8x equals 0. So x is 0. What y'all got? So find out what y is. Come back up here. Multiply negative 3 times minus 6. I'm supposed to put in an x right there. But now, because of my work, I know what x is. I'm going to take that, plug it in, get 0, and y is negative 6. So what happens at the point 0, negative 6? These 2 lines intersect because this system is, because they have different slopes. As soon as you recognize they have different slopes, you know what type it is. That's what those problems down there at the bottom of your page, that's what the first thing that you're going to check is. I got two two little questions of you being able to identify whether it's independent, dependent, or inconsistent. Then there's 4 problems of graphing. Okay, if you're not quite ready to do the substitution or elimination yet, you're okay. That's what we're going to practice all day tomorrow. We get all this good. We go over the homework. You guys feel comfortable with identifying the type, identifying the number of solutions. We'll take the test Wednesday. If not, we can push it back and take Thursday. That sound good? Good day.